Hey everyone, my name is Jessica Laughlin and I am a software engineer at Materialize. Today I'm going to be presenting Gone Streaming, dbt and Materialize. So a little bit about me. I have worked at Goldman Sachs, Bluecore, which is a marketing tech startup in New York, and I currently work at Materialize. If my name is even vaguely familiar, I wrote a bit about Airflow when I was working as a software engineer / infrastructure engineer for the data science team at Bluecore. But I'm currently building the world's first SQL streaming database at Materialize. I've worked at Materialize for a bit over 2 years now and have worked on a lot of aspects of Materialize, but I've focused a lot on external integrations. So how we get data in, how we send data out, and how we interact with the ecosystem of data products that exist in the database space. So that being said, I've spent some time with things like Postgres, Kinesis, Kafka, but I'm really excited to talk today about how dbt and Materialize can work together to transform your streaming data in real time. So the first chunk of this talk, I'm going to talk a little bit about dbt, but I'm primarily going to try to convince you that dbt cannot transform streaming data efficiently in real time. And I'm going to follow that up by a chunk about Materialize, where I will, again, try to convince you that using Materialize is the only way to transform streaming data efficiently in real time with dbt. I'm going to be walking through some samples and demos and smaller problems as we go through this talk, but at the end, I will work my way through a full-fledged demo that will be available on the Materialize GitHub repo. So if you are Materialize curious, please feel free to check that out after the talk. Reach out to us on Slack, open issues. Love to chat about it. Without further ado, let's get started. So let's start off by talking about dbt. dbt stands for Data Build Tool, and the goal of dbt is to completely take over the T, or transformation step, in your traditional ETL, extract, transform, load pipeline. To understand how it would do that, let's take a closer look at how dbt actually works. dbt performs transformations of your data directly in your data warehouse using dbt models. So let's say you have some sort of data warehouse that has data in it. dbt supports connections to lots of different types of data warehouses. So this might be MySQL or Postgres or BigQuery or Snowflake, or as we'll talk about later, it could be Materialize. And historically, if you wanted to transform data in your data warehouse, you might write your own SQL to do it. You might have to pipe data between data warehouses, or you might have to pull chunks of data into memory to perform computations and then spit it back into your data warehouse. But using dbt, all you need to do is define a dbt project that connects to that data warehouse and define the transformations that you want to perform in your dbt model files. We're going to talk a bit more about model files in a minute, but all you need to know for now is that dbt will transform your data each time you execute dbt run. Each time you execute dbt run, each of your models defined in your models directory will be executed. This means that the SQL statements within the models will be executed against the existing data in your data warehouse, outputting some transformed data that will still be contained in the same data warehouse. At this point, it might be obvious that dbt models are doing most of the work in dbt transforming your data inside of your data warehouse. The good news is that dbt models are pretty simple to create. They only have 2 components. The first component is that a dbt model is a SQL statement that expresses your desired data transformation. The second component of a dbt model is a materialization parameter that determines how your transformed data is persisted in the underlying data warehouse. That might feel a bit abstract, so let's make it more concrete. Imagine that we had this stock price table in our data warehouse. The stock is simply a text field of the ticker stock symbol, and the price is the price of a stock at a given point in time. This table on its own isn't super interesting. What you'd likely want to do is perform some sort of calculation, aggregation, or maybe even something predictive on this table. For our example though, let's imagine that we just wanted to know what's the average price per stock. Luckily, we can easily define that using a DBT model. On the right-hand side is our select statement defining our DBT model. So we want to select stock and average price from stock prices, and then group that by the stock. This is the first half of the definition of our model, and all we have left is to determine the materialization parameter of this model. DBT supports 4 types of materializations out of the box. So as I've mentioned a few times, the materialization determines how the transformation is persisted. So the 4 built-in options are view, table, incremental, and ephemeral. When you DBT run a model with any of these materialization types, you are persisting your transform data as a view, a table with refreshes, which looks a little bit like a traditional materialized view, or a CTE, which is a common table expression. The good news is that any of these data types that are stored and persisted in your database are great at transforming batch data. The bad news is that none of them are sufficient to transform streaming data in real time. To understand why, let's revisit our stock price table from before. So this is the same stock price table that we saw, and here is the transformation that we performed using our DBT model. So we have the average price per ticker stock symbol. Now, my question is, what happens when new data arrives in the underlying stock price table? What do you expect to be returned to the user if they are looking for the average stock price of Amazon? That depends on the materialization type that was chosen for the model. Each time a model with a view or an ephemeral materialization is queried, the data will be retransformed. So the user will get the up-to-date result, meaning the correct average price for the Amazon stock, but you are paying some cost in terms of computation and in terms of time each time it's queried and each time it needs to be updated. On the other hand, models that use a table or an incremental materialization will simply return stale data. In order to include that new row of data in your transformed model, you're going to need to DBT run that model again. So I claimed earlier that these existing DBT materialization types are sufficient to transform batch data, but insufficient to transform streaming data. To make sure that we're all on the same page, let's just go over what batch data is versus what streaming data is. Batch data is data that arrives in discrete batches. That could be once a minute, once an hour, once a day. The interval doesn't matter. All that matters is that there is no new data that arrives between batches. Streaming data, on the other hand, arrives continually and at no particular schedule. So there's no way of knowing when you will receive the next row or bit of data, or how long it will be until then. So now that we've clarified what I mean by batch and streaming data, you might be wondering why I said DBT and its existing materializations are sufficient to transform batch data while they are insufficient to transform streaming data. To understand, let's step back to our stock price example. Here we have our stock price table on the left, and on the right we have our transform table that was created via DBT run. If we have batches of data arriving in our stock price table on the left, and we are certain that we will not be getting new rows in between the batches of data, that means that we can reliably and efficiently schedule or trigger DBT runs to retransform that data in between batches. This means that view and ephemeral models will still perform the same transformations and they'll still have the same costs, but table and incremental models will never return stale data. So we are able to efficiently transform batch data using dbt by scheduling dbt run between batches. Unfortunately, we're unable to do the same thing with streaming data. By definition, streaming data arrives continually and at no particular schedule. So there's no point at which we could execute, schedule, or trigger a dbt run to keep models up to date. This is why I said at the beginning that dbt and its current materialization types are insufficient to transform data efficiently in real time. So what can you do if you have streaming data but you want to transform it with dbt? There are two ways that dbt has suggested working around the issue. I talk about this a bit in a blog post that I'm happy to link later, but for all intents and purposes, using Materialize with dbt is the only way to transform your streaming data in real time. So this seems like a good jumping off point. Let's move on over to Materialize. I feel like a lot of y'all might have been familiar with dbt. This might be your first introduction to Materialize, so welcome. Materialize is the first true SQL streaming database. It's built on top of differential data flow and timely data flow, which were led by Frank McSherry, who is a co-founder of Materialize, if you are familiar. Materialize itself is wire compatible with Postgres, and it will return correct answers to your queries in milliseconds. So at a pretty high level, this is how Materialize works. There is the PostgreSQL compatible interface, so you interact with Materialize via SQL statements, and we turn your SQL statements into differential and timely data flows. We ingest different types of streaming data, so Postgres bin logs, we ingest data from Kafka, Kinesis, from files from S3, that's the newest source, and you can read data from Materialize in a few different ways. You can query Materialize interactively, once again using PostgreSQL. You can power real-time dashboards, or you can send data back out to streaming systems such as Kafka. We will be supporting more types of syncs in the future. So now that we've taken a high-level look at what Materialize is, you might be wondering how Materialize enables dbt to transform streaming data in real time. And the answer is we use Materialize's superpower, incremental materialized views. These are materialized views that never go out of date and never do any more work than necessary. We are able to maintain incremental materialized views by backing the data that's stored in Materialize with differential and timely data flows, which I mentioned in the last slide. To see what this looks like in practice, let's step back to our example. So we're back to our stock price table, but imagine that we have a new row of data flow in. And after that, there might be another new row of data. As this is a stock price table, you can imagine that new prices would be flowing in every second, every minute, every hour. If we were creating a model on top of this table and we used a view or ephemeral model, which as you might remember are backed by views and CTEs, the model would recompute the average price each time the user queried your model. If you were using a table or incremental model, which are both backed by tables, your model would return stale data until you dbt ran it again. However, if you were using an incremental materialized view with Materialize, your model would return the correct answer without having to recompute or dbt run your model again. So how do incremental materialized views work? As the name suggests, incremental materialized views maintain correct results incrementally. So instead of having to recompute the average value each time, or instead of returning stale data, Materialize maintains an incremental average of each stock price. In Materialize, this looks like a running sum of the prices divided by a running count. So when our first additional Amazon stock flows in, this looks like summing the two stock values, which would give us 6,755, and dividing that by the running count, which would be 2, outputting an average value of 3,377. As our third Amazon row flows in, you'll notice that we do not redo any work. We use the running sum that we generated from the previous row, so 6,755. We sum that with the new price of Amazon, 3,378, and we divide that by the new running count, which is 3. So for the sum, we get 10,000, and then for our new updated running count, we get 3,378. So to recap, incremental materialized views maintain up-to-date results of your queries without needing to be dbt run. They only perform work when necessary, so we didn't have to recompute the average from scratch. And because we are maintaining the result incrementally, we are able to return correct results within milliseconds. So I've said this a few times during this talk, but just to be super clear, as new data flows into your streaming source, your model will only be able to return correct results without recomputing if you use Materialize's materialized view materialization for your dbt models. It will not be able to do this with a view or ephemeral materialization, and it will not be able to do this with table or incremental materializations. So for this reason, dbt and materialize together are the only way to transform your streaming data efficiently in real time. In case you missed it, there is another incredible bonus of using dbt and materialize together to transform your streaming data, and that is that you will be able to dbt run your models once and never again. Models backed by Materialize's incremental materialized views always have up-to-date results to your queries. They never have stale data, they never recompute your data, and so you never have to worry about scheduling dbt runs or triggering dbt runs. Anytime you query a model backed by a materialized view, your results will be up to date. So at this point, I hope you are excited about dbt and materialize and transforming your streaming data in real time. So let's take a look at what it would actually look like to work with some stock data and with dbt and materialize together. As a reminder, this project is available in the Materialize GitHub repo, so please feel free to check it out on your own. So now that we've talked a lot about dbt and materialize, let's walk through a demo project together. If you go to Materialize repository, under the play directory, you can find a project called Materialize Cloud dbt. And this is just a small dbt project that lets you connect to the cloud offering of Materialize. So I have this project open in my Visual Studio Code, so let's walk through it together. For those of you who don't know, this is a dbt project.yaml file, which is the highest level config file for a dbt project. It gives us some useful information like the name of the project, the profile of the project. So dbt profiles are what tell dbt which dbt adapter to use. So for those of you who aren't familiar, a dbt adapter is the piece of code that connects dbt to a data warehouse. So we have a dbt materialize adapter, and that's what you'd need to use to connect dbt to materialize. It's the same thing that you'd use for other databases like BigQuery or Snowflake. This is just the materialize specific one. And you can see that I'm using a profile called test cloud. This is just a set of information that allows dbt to connect to a materialized cloud instance. So here's a sample of that type of profile. You can see that the type here is materialized. That tells dbt to use the dbt materialize adapter. I have some cloud host information and other authentication information that allows dbt to actually connect to my cloud instance. And then here you can see that our source path is just the models directory, which is open on the left. And models, as you may remember, are where we actually perform transformations of the data in our materialized data warehouse. So let's take a look at our models together. The first model that we're going to care about is called market orders raw, and it's what creates a materialized source in Materialize. Sources in Materialize are how you ingest data from other streaming systems or databases or even flat files into Materialize in order to transform that data. In this instance, we're ingesting data from PubNub, which is a publish-subscribe service. They also have some free data streams, so that's what we're reading in this demo. We're reading from their PubNub market orders data stream. But the PubNub market orders data stream, called market orders raw, only comes in as text. So we are going to create a market orders model that breaks that text into useful fields. So the first field is symbol, which is just the ticker stock symbol as text. And the second field is bid price, which is the price of the stock cast as a float. Once we have this market orders model available, we're going to be able to use that to create the running average that we saw in our previous slides. So this is the select symbol and average bid price from the market orders model and group that by symbol. You may have noticed that this model and the market orders model both are materialized view materializations. So this is in contrast to the view, CTE, incremental, or ephemeral models that we've talked about. This is what tells dbt and the dbt materialize adapter to create an incremental materialized view in Materialize. So now that we know what our models look like, let's run them. So I'm in my iTerm, I have the Materialized Cloud dbt project locally, and I'm in that directory. The first thing I'm going to do is create a virtual environment. And then once I have that virtual environment, I am going to pip install dbt materialize. So this installs the dbt materialize adapter. It also installs anything you need from dbt, so you don't need to install both. It's actually a bit lighter just to install the dbt materialize adapter. Now, once that's installed, we can just check that our test cloud profile and our dbt materialize adapter can connect to my cloud instance. Ta-da! It can. That's great news. So now that we know we can connect, let's actually dbt run our models. As you may have remembered from earlier in the talk, I said that when you use the materialized view materialization, you can dbt run your models once and never again. So this was our single dbt run. And with our dbt run, we created the source, the thing that brings data into Materialize. We parsed that source into useful columns. We created an index, which is an exercise left to the reader, and we created our market orders average view, so the view we've been working with for the entirety of this talk. So now that our models have been run, let's take a look at that data changing in real time in my Materialize Cloud instance. In order to see our data change in real time, I'm just going to use this watch command, which every second will output select star from market orders average. Ta-da! This is it. This is the magic. We are not recomputing these averages each time a new row of data flows in from PubNub. We are not having to dbt run this model again. As you may remember, I ran this model once. I am never running it again. But by backing my model with Materialize's materialized view, I am able to maintain these averages incrementally. So each time my watch command queries Materialize, I am getting the up-to-date average without doing any more work than necessary. So to bring it on home, using dbt with Materialize is the only way to transform your streaming data in real time. I hope you enjoyed this talk. I hope you try it out at home. And please feel free to reach out on GitHub or Slack because we are really excited to get you all transforming your streaming data with dbt and Materialize. Thank you.